Hi guys. I told you I was going to have a couple practice problems for you. And the first one that I want to cover is algebraic vector addition. Now this problem's coming right from the assignment that we did when we first learned this concept, so if you want to follow along, that's where I'm at. Okay, so I have two vectors, vector A and vector B, and I need to see what the resultant vector is between the two of them. So let's start by recording what these vectors are. Let's draw them. Vector A is 90 grams at a positive 70 degrees from the negative y-axis. So reminder, counterclockwise is positive degrees and clockwise is negative degrees. So since this is a positive 70 and a positive 35, I'll be moving counterclockwise from whatever axis it's telling me I'm working with. So for this first one, positive 70 from a negative x-axis. So here's my positive x-axis, here's my negative x-axis. So instead of moving clockwise, I'm going to move counterclockwise. Okay. So counterclockwise, 70 degrees, so 45 is in the middle. Give myself a reasonable angle here. And I am clockwise 70 degrees from the negative x-axis. Now, this is my vector A, right? And vector A has a magnitude of 90 grams. So when I draw my vector B, if this represents 90, then I need to have an equivalent length that would represent 65 compared to that. Okay? So vector B, 65 grams at a positive 35 from the positive y-axis. So here's my positive y-axis, and then I'm going to go counterclockwise 35 degrees from it because it's a positive 35. So 35, a little bit less than 40, and it needs to be roughly 2/3 the length of our vector A for the 65 compared to the 90. So this is my vector B, and it is 35 degrees clockwise from my positive y-axis. So there's my two vectors. And with my two vectors, I can graphically or visually look at their sum or the resultant. So if I pick up one of these vectors, and it doesn't matter which one, but if I pick up one and I place the tail of the vector on the tip of the second vector, then I would be able to look at my resultant, okay? So I wanted to move vector B down here. Well, the way that we add vectors is we go, here's my first vector, I'm going to add the second. The way I add the second is by putting the tail of the second onto the head or the tip of the first, and I can't change its magnitude and its direction, but I can change its location. And then I'll get a resultant vector, maybe I'll do that one in green, which will go from the tail of the first to the tip of the second. So my resultant vector would be right about there-ish. My resultant vector. Okay? So visually or graphically, that's what are the magnitude or the length of our resultant, and that's the direction of the resultant. We can calculate some angle from an axis to represent that. We need to do this algebraically now, right? And the way we do that is by breaking up our A and B vectors into its x and y components. So when you approach a problem like this, make the same list of knowns and unknowns. So I have my vector A, And vector A can be broken up into its x and its y components. And vector B can be broken up into its x and its y components. And then my resultant vector will have x and y components as well. Here's my list of knowns and unknowns. I'm just going to start filling it out and making those calculations. Like A has a magnitude of 90 grams. And B has a magnitude of 65 grams. Okay. Well, if I look at A can be broken into its x and its y components. Like that line I just drew there, that would be A sub y. And then right here, that would be A sub x. If this is my angle, ignore the green resultant vector for just a moment. Just concentrate on this triangle right here. Here's my angle, opposite would be A sub y, and adjacent to that angle would be A sub x. So if I'm looking at A sub x, I want to use a trig function that includes the adjacent. So our trig functions, sine, cosine, tangent. Okay. And I said I need an adjacent, so I'm going to choose cosine. The cosine of 70 degrees is going to be equal adjacent, which is A sub x, over my hypotenuse, which is A. Now I'm not solving for A sub x over A, I'm just solving for A, so I need to isolate it. I'm just solving for A sub x, so I need to isolate it away from A. So it's divided by A, so I'll multiply A to both sides of my equation. Now it cancels here, and so A multiplied by the cosine of 70, that's going to equal A sub x. Okay, I'm going to plug that in my calculator. So A, which was 90, multiplied by the cosine of 70. Now make sure you're in degree mode, because that's going to be important. Now I'm not going to round this number yet for sig figs, because this is an intermediate calculation. So I have 30.7818. Now A was 90 grams, and cosine theta is unitless, so my final unit here would be grams. I'm going to record that right here, but this is just a magnitude of A sub x. It's not the direction component of it. So when I look back at my graphical analysis of this, notice how A sub x is in the negative x direction. It's not over here. It's not on the positive x side. It's on the negative x side. So I have negative 30.7818 grams. Okay. A sub y is opposite from my angle, and so I'm going to use sine because it has the opposite component. So if I take my sine of 70, that will equal opposite A sub y over A. And again, I'm not solving for A sub y over A, I'm just solving for A sub y. So since it's divided by A, I'll multiply A to both sides. It'll cancel there. And A sine 70 will tell me A sub y. Okay. So I'll take A, which is 90 grams, and I'll multiply that by the sine of 70. And again, intermediate calculation, so I don't want to round it yet, 84.5723 grams. Now let's move on to b. b sub x and b sub y. When I look at my b vector, here's my b sub x, and then right there is my b sub y. Opposite from my angle is b sub x, and adjacent is b sub y. That's different than what we had below, so that's why it's really important that you draw your triangle and analyze what is opposite and what is adjacent for the assigned angle. So if I'm solving for b sub x, I need to use a trig function that addresses the opposite component for my angle. So I'm going to choose sine because I have that opposite component. So if I have sine of 35, that's going to be opposite, which is b sub x over b. And I'll multiply both sides by b to isolate it. And so I have b multiplied by the sine of 35 equals b sub x. b has a magnitude of 65 grams multiplied by the sine of 35, 37.2825. Now that's a magnitude, not a direction, and I'm just recognizing and remembering I took the magnitude, but I didn't consider the direction on my a sub y. I did it for a sub x, but a sub y is a negative. If it was positive, it would be up here, but it's not. It's in the negative y. So I need to include that negative sign now that I'm talking about the direction component. What about b sub x? b sub x has a magnitude of 37.2825 grams, but it is also in the negative x direction. So that's going to be a negative 37.2825 grams. If I want my b sub y, I'm adjacent, so I'm going to choose cosine because I have that adjacent component. Okay? So we're going to take cosine 35 is going to equal adjacent b sub y over b, isolating b sub y by multiplying b to both sides. b cosine 35 will equal b sub y. Magnitude is 53.2449 grams. And then let's look at direction. So y component is in the positive y. So this will just be the positive 53.2449 grams. Okay. On the next video, I will show you how we calculate r sub x and r sub y, and then we use that to get our r and our theta value for r. Because just a quick reminder, r sub x is a sub x plus our b sub x, and we just calculated that, and r sub y is a sub y plus b sub y. Okay. So next video, I will finish up this problem.